Hey everybody, Mr. Mack here, and I'm looking at part 2 here of this cumulative review for you guys for chapter 7. In this section we're going to focus on inverse trigonometric ratios. So this is an old quiz that I gave that we're using for a review. And we're going to solve the following right triangles using Pythagorean theorem, the trigonometric ratios, and the inverse trigonometric ratios. Round all answers to nearest tenth. Okay. So we got triangle ABC right here, and we need to solve all parts of the triangle. So that means that we need to find all three sides and all three angles. Well, right now we have two sides, two legs, and we know the angle between them is 90. So we need to find A to B. We need to find little c here. This is our hypotenuse. And we need to find, let's call this angle X and angle Y. Why don't we get side C first? So we can use Pythagorean theorem. A squared plus B squared equals C squared. And my A here is 5. It's a convention to call the side opposite little a from big A. So this is angle B. Opposite of angle B would be little b, and that's 15. So let's put them in. 5 squared plus 15 squared equals C squared. So we got 25 plus, what's 15 squared? That's 225 equals C squared. So add those together, I got 250. And now I got to take the square root of 250. And so 250 breaks down into 5. So I know 5 times 25 is 5, so it's going to be 5 and 50, 5 and 10, 2 and 5. I have one pair of 5s, so that means a 5 comes out, and the 2 and the 5 stay in, so I'm going to multiply them together and get root 10. Okay, so I've got C. Now let's find, how about we get angle X first? So I could use any of the three sides since I know them, but I prefer not to use the one with the square root. So how about we use the side opposite leg here. So little b would be the opposite leg. And then A would be the adjacent leg. So we know SOHCAHTOA is the way we can remember our equations for our trig functions. So SOHCAHTOA. And so if we're going to use the opposite leg and the adjacent leg, we need to use tangent. So tangent of our angle X equals the opposite, 15, over the adjacent, 5. And I can simplify that if I want. And now I need to find, I'm trying to solve for x here, but it's wrapped inside this function tangent. So the way we get rid of this tangent function is to take the inverse of it. So if I take the inverse tangent of both sides, I will get x equals the inverse tangent of 3. Now we can go to our calculator. Make sure you're in degrees here, not radians. And we're going to do second. Now I'm going to do a tangent right here. It's the same thing as arctangent. It also means inverse tangent, tangent -1. It's just another way of writing it, and it's not so common on most of our calculators, but it is possible to see. So I'm just going to write arctangent of 3, and then if we see this preview window up here at the top, it shows the notation that we're used to. So this is what we want, and we hit equals 71.57, 71 point, what is it rounding to the nearest tenth? So this would be 71.6. 71.6 degrees. Now, I know that angles A and B are complementary. They add up to 90. I know 180 in a triangle, but I've already used 90 for the right angle. So there's 90 available. So that must mean that x plus y has to be 90. I already found x. X is 71.6 degrees plus y equals 90. So I'm going to subtract the 71.6 to both sides, and I get y equals, okay, what's this going to be? 20, 90 minus 70 is 20, 19, 18.4 degrees. So I have now, whoops, this one, all 3 pieces of information that we're missing in this triangle. Let's have a look at this next one. Let's get a little bit more width here. So we have triangle ABC, and we have a leg of 18, an unknown leg, and a leg of 24. We can use the Pythagorean theorem once again. So let's do that. Let's lead off with that. A squared plus B squared equals C squared. And so we're missing side A here. How about I do it this way? Let's say a squared equals, it's going to be 24 squared minus 18 squared. I'll just do this on my calculator. 24 squared minus 18 squared. And that gives me 252. So a squared equals 252. And I'm going to take the square root of that, and does this simplify? So let's see, 126, 63, 21, 3, and 7. That's it. I've got 2 2's. I have 2 3's. I have an odd 7. So this is going to be 2 times 3 root 7, or 6 root 7. Okay, so this leg right here is going to be 6 root 3. Sorry, I said 6 root 7 and then wrote 3. 6 root 7. That's a 7. Okay, so now we still have 2 angles that we do not know. We can call this one angle X, and angle y if we wanted. And let's get angle x first. So we could go with using, so for angle x, this is the opposite leg, and this is the adjacent, and this is the hypotenuse right here. So I could go with this opposite, but I don't want to deal with the root 7. How about let's do the adjacent and the hypotenuse. So which trig function do we use for that? It would be cosine, because cosine of an angle, I'll just put the equation here, is the adjacent leg over the hypotenuse. So let's substitute what we know. Cosine of x equals 18 over 24. We could simplify that if we want. Why not? So a 6 comes out of both 18 and 24, so that would give us 3. A 6 out of 18 is 3, a 6 out of 24 is 4, and then we're going to take the inverse cosine of 3/4. Go to our calculator, inverse 3 divide 4. Let's preview that. That's what we're doing. We're in degrees, equals 41.4 degrees. 41.4 degrees. Okay, we know. And so we know y here has to be the complement of that. So we know y must be 90 minus 41.4. Okay, so 90 minus 40 would be 50. So go 49, 48.6 degrees. So 48.6 and 41.4 add up to 90. There are my solutions. So this is 48.6, and this one is 41.4. That is a 4. Very good. Okay, let's take a look at a word problem here. Johnny's standing on a building 75 feet at eye level above the street. He is standing 75 feet at eye level. So his eye is 75 feet above the street. This vertical distance here. He sees his buddy Connor on the other side of the street, which is 60 feet from the building. So this is, 40 feet from the building. What is the angle of depression from Johnny to Connor? So this is Johnny here. That's J, and this is C. So maybe I can say this is point J and this is point C right here. Angle of depression is measured from the horizon down. So here's our horizon. We want this angle right here. Well, what do we know about all horizontal lines? Here's another horizontal down here. All horizontal lines are parallel to each other. So therefore, this angle here must be congruent to this angle here because of alternate interior angles. Okay, so if we find this angle, which is inside this triangle, then it's the same as this one. They're congruent. So we know this side, this leg opposite of the angle where Connor is, 75, and we know that this side of 40 is adjacent. So we should use the tangent function tangent of angle where Connor is, let's call that C, equals the opposite leg divided by the adjacent leg. We're solving for an unknown angle. We use the inverse tangent of 75 divided by 40. And we go, that simplifies, but I'm just going to put it in as it is. The inverse tangent of 75 divided by 40. Okay, there's my preview. That looks good. Equals 61.9. 61.9 degrees. So these two are congruent. That means this angle is 61.9 degrees. By the way, Connor is looking up at Johnny at 61.9 degree, and this would be angle elevation. So this one is an elevation, and this one is a depression. Very good. There's that one. Solve for the variables round to the nearest tenth. Okay, we've got a right triangle here. Let's make this yellow. So this is a right triangle, but this bigger triangle here is an orange, is also a right triangle. However, this triangle right here, that is not a right triangle. So be careful here. We know that our trig functions and our Pythagorean theorem and our special triangles, all the things in this unit require the triangle to be a right triangle. Okay, so what do we have? We know this is 4. We know this is 8. This is in inches. I should have a unit here, inches. So this is 4 and this is 8 and this yellow triangle. That means that we could find everything, right? So we can find angle x. We could find this side y. Let's get angle x first. So 8 is the opposite leg. 4 is the adjacent. We're going to use tangent of angle x equals 8 over 4. Well, 8 over 4 is 2. So let's take the inverse tangent of both sides. And I'm just going to take the inverse tangent of 2. Nope. Inverse tangent of 2. That's not what I wanted. I want to do inverse tangent of 2. There we go. That's better. 63.4. So this angle is 63.4 degrees. Now, this angle here is going to be 90 minus 63.4 degrees, which is going to be 30, 31, 32, 33, 36.6. So that's going to be 36.6 degrees. Sorry, 26.6. Trying to do it in my head, and I got this, all right? Yep. So this is going to be 26.6 degrees right there. Okay, let's find y. How about we just use Pythagorean theorem here? We got a squared plus b squared equals c squared. We got our legs of 8 and 4, and y is our c variable. 64 plus 16. And let's add those together. That's 80. I'm going to take the square root of 80. It says round to the nearest tenth. I guess we could do that for this one. I don't know. I kind of want the angles to the nearest tenth. Let's just simplify this in radical form. For root 5. So 4 root 5 is y. Okay. Oh, we have a 28 here also. That's kind of nice. Yeah, actually, we probably could have not. I could have made this a little bit harder if I didn't give you that, but let's go ahead and take it. So we know the big triangle, the sum must be 180, right? So, I mean, okay, so let's say this is ABC right here. And we're looking at this big triangle. So maybe let's color this in blue. I got this big triangle right here. And not to cover up my previous answer. So we know A plus B plus C equals 180. So A is 28. B, look, there's two parts to B here, right? There's a W angle, and then there's the 26.6 that we already found. Right? This is B right here, this section, plus 90 equals 180. Now we can solve for W. We can add these other angles together. And so 28 plus 90. So let's do this. We have the 180. So I'm going to write this. We have the 180, and we're going to take 90 away from that, and we're going to also subtract the 26.6, and then we're also going to subtract the 28, right? So I'm just subtracting these three numbers here, these constants, to the other side. And let's pop it into our calculator. So 180. I mean, you could do this by hand if you're not into the whole brevity thing, but let's 180 minus 90 minus, I feel like there's a 28 in there. 28, yeah, 26.6. I'm not doing this in order. 26.6. So I've got 180, and I'm subtracting these three other numbers, right? 90, 26.6, and 28, and equals 35.4. So 35.4 is W right there. Okay, excellent. I like that problem. Okay, we got one more here. This cruise ship problem. We got a direction. This is actually a direction, as we discussed before. It's not a bearing. Cruise ship leaves Miami south 30 degrees east. Okay, now I'm not going to do this to scale. We could, but it's hard to do it on the computer to scale. So let's see if we can get away with not having to do it. So I'm going to draw a north line, and then we're going to go 30 degrees for 30 kilometers. So something like that, maybe. And this is going to go, I'm going south. Goodness. Okay, I'm going southeast. All right, so how about let's put up another point here, and so this is south, and I'm going to go south 30 degrees east for 30 kilometers. So this is going to be 30 degrees here, and this length is 30 kilometers. So I started at A, I'm now at B, and now we are going to turn, and we're going to go north 60 degrees east. So I need to draw a north line here. I'm going to get there. And we're going 60 degrees here. So we're going to go 60 degrees for 40 kilometers, something like that. So this angle is 60 degrees, and we are going for 40 kilometers. how far and what direction is the ship from Miami? All right, so this is point C. And we want to know this distance right here. And we also know, we want to know the direction. Okay, so I need to do another north line. Okay. Cool. So let's think about our properties of parallel lines. We know that if we north-south lines are parallel, and so alternate interior angles are going to be congruent. So that means that this angle is congruent to this angle. And 30 and 60 give us 90. So this is a right triangle. Oh, that's super nice. What a coincidence. So I want to shade that in, but let's see. Won't let me do it. Oh, come on. Stop. To fill this, maybe. Let's try it now. So, very good. So D is the hypotenuse of this right triangle with legs 30 and 40. So we could use the Pythagorean theorem here. 30 squared plus 40 squared equals D squared. So I hope you guys start to see some of the numbers that work in the Pythagorean theorem. This is a 3, 4, 5 triangle. It's just expanded. It's just scaled up, right? So if I add these together, I get 2,500, and then so D is going to be 50, right? So this is a 3, 4, 5 triangle, or multiplied by a scale factor of 10, right? 30, 40. D is 50. So this is 50 kilometers is the distance from the ship to back to the port. Is it a port? Miami, yeah. So what about this, the direction here? So direction, we're going to say, well, we're not really sure how much south or north we're going here. That's the way I drew it. I mean, I don't really know. So we can't just assume, oh, that looks like it's just due east from C. It's pretty close. So what I think we should do is we should find this angle right here. Let's call this X. We should find this angle. And if I know this, if I know angle X here, and I know this angle is 30, I know that this angle here is congruent to this big angle here. Because again, these are alternate, let's put doubles on it. These are alternate interior angles with these two parallel lines. These north lines are parallel to each other, right? So, I mean, it looks like this, right? I have these two north lines, and then I have this segment in between, and I know that these are congruent. This is the situation. I just have a triangle in here, and it's harder to see maybe, but there it is. So let's find it. Let's find this X value. So how do we do it? Well, I know all the sides of the triangle. I could use any trig function I want. How about we go tangent, since the 40 and the 30 were originally given? So tangent of X equals the opposite leg 40 over the adjacent leg 30. Tangent of X equals 40 over 30. Of course, that simplifies to 4/3. So we're going to do tangent, inverse tangent of 4 over 3. And calculator, inverse tangent of 4 divided by 3. Let's preview that. I'm in degrees. Looks good. 53.1. So 53.1 degrees. So this is 53.1. So this angle over here, let's call it Y, is going to be equal to 53.1 plus 30, which is 83.1 degrees. So if this is 83, so if this is 90, it's going due west right here. But because it's 93, it means that A is actually more north than C, despite how I drew it, right? So this angle right here is 83.1, so that means how far, what is the ship from Miami? Well, of course, maybe I should read the question. We're actually from Miami and not from the ship. So I really need this angle right here, which is fine because we know that these two angles here are supplementary because they're same side interior. But we also know that it's supplementary with this angle here. So let's subtract 83.1 from 90. That was my wrong window. So we're going to subtract 100, let's redo this. So we got 180 minus 83.1. Is that right? 83.1. Yep, that'll do. 96.9. Okay, so this angle is 96.9. All right, so this angle right here is 83.1. So that means that in order to get to, we've got to go, the ship this ship here is south 83.1 degrees east at, and then we'll say 50 kilometers away. All right, there we go. We do this by scale, we see it a little more clearly. It's actually, the ship is actually below, something like this, below A. So C here is going to be below, south of A. Okay, everybody, I'm going to stop there. I hope that makes sense, and I'll see y'all later.